Hello everyone, welcome to this next video on complex analysis. In this video we shall see question from 2003 and this question is also from bilinear transformation. By now you must have learned this formula to calculate what is a binomial transformation. So here in this question we are given the point 0, 1 and infinity. They are in the z plane map correspondingly to the point minus iota, infinity and 1 in the w plane. So they are asking what is this transformation f. So for that we'll use this formula. So notice here that for the term w2 we have infinity and for z3 we have infinity. So we have to solve this by taking its limit. So in the initial step we will not substitute these values, so we'll keep them as such. So it would be z minus 0, z2 is 1 minus z3 as such, and right, yes, so and z1 is 0, z2 is 1 and z3 as such minus z. And here on the right hand side we won't substitute for w2. w1 is minus iota, so this is this thing, w2 as such, w3 minus the value is 1, w1's value is minus iota minus w2, and then we have w3 1 minus w. So now from these two terms we can take z3 common. So here we would have z multiplied by z3 multiplied by 1 by z3 minus 1, and here we have minus 1 and we can take z3 common, so it would be 1 minus z upon z3. So this z3 and this z3 cancels. On the right hand side we have w plus iota, and again we can take w2 common, so it would be 1 minus 1 upon w2, then divided by w2 common, so it would be, or we can take minus w2 common, so it would be iota divided by w2 plus 1, right, and 1 minus w as such. So from here w2 and w2 cancels. So now we can substitute the values of z3 and w2 as they goes to infinity. That means 1 upon z3 would go to 0 and 1 upon w2 that will also go to 0. So we are only left with z into 0 minus 1, and then we have minus 1 multiplied by 1 minus 0, and on the right hand side it would be w plus iota, and then we have 1 minus 0, and then we have minus 1, and then 0 plus 1, 1 minus w. So we can simplify this. It would be, so this minus 1 cancels with this one, so it on the left hand side we only have z, on the right hand side we have from here w plus iota, and from here we can multiply this minus 1 inside of this bracket, so we would have w minus 1. So from here we are to extract the value of w, and we are done. So for that what we are doing, we can simplify this a bit. So this thing divided by 1, so we can write by applying componendo and dividendo. In that we just add the numerator and denominator and put it in place of numerator, and then we divide numerator with denominator and put it in place of denominator. So similarly we do the same with the right hand side. So we would have something like this. So we can solve this. So from the new denominator this w term cancels, so we are left with iota plus 1, and here we are left with 2w plus iota minus 1, and so basically this has made more of a mess. So what we can do instead is we just have to simplify this, right? So for that, we can simply multiply by this term. So what we can do here is, instead, we can multiply this term w minus 1 on the left hand side. So we'll be having something like this. So we can collect now the terms corresponding to w. So we would have w into z minus 1, and then on the right hand side we would have iota plus z. So w would simply be z plus iota divided by z minus 1. So this is our final answer. So let us look at our options. So from here, z plus iota divided by z minus 1 is the correct option. So here option number C is the correct option. So I hope you understood this bilinear transformations well by now. So that is it for this video. I'll see you in the next one.